Good morning, one and all. Welcome to the third day of National Level Online Faculty Development Program on current research trends in artificial intelligence and machine learning. I welcome you all. I welcome the resource person, MN Sai Yaswanth Moorthy Garu. So yesterday was a nice session with the basics, how to solve the problem applying the AI techniques and machine learning using Python. So today we will be knowing more information about deep learning. I hope all will get some new insights because Sai Yaswanth Moorthy Garu is from industry. So we should know some more things, even if we know the basics in the perspective of industry. So happy learning. Now I request Yaswanth Moorthy Garu to take up the session. Thank you.
Thank you so much, ma'am. Thank you, one and all. Good morning and warm welcome for all students and professors. So, yesterday we have seen how to start looking at a problem statement in the case of machine learning and few other techniques. So, today we will be seeing how actually the artificial intelligence concepts that we were talking about, how the human intelligence can affect and how human intelligence can be relied while creating a machine to understand for itself. So we will go into, we will dive deep into this kind of learning mechanism. So that's the reason we can call it as deep learning. So AI, which means it holds of data science, it holds deep learning, it holds machine learning, it holds a lot of other techniques, reinforcement learning, and much more things, which we are not even aware of those things. See, like an emerging field which always constitute of a lot of other things. While we are speaking over here, there may be someone in some part of this world developing a new kind of concept to make an artificial intelligence learn by itself, and he can name it for itself. So these supervised, unsupervised, and these basic mechanisms were built several hundreds years ago, so that any human being who wants to make things easier for the mankind can use the techniques and make use of mechanics and make it work faster. So those things are getting applied these days due to the advancement of technology and due to the reliability of technology. Now that we have huge amount of nanotechnology and huge amount of cloud environments, the accessibility of data, the usage of techniques or the technology has been widely exposed. Now this is helping these algorithms which have been developed or been guessed 1,000 years back or 100 years back come into existence or coming to reality. And the same way, now if we are going to think in a perspective where it can be helpful for the future mankind, it can also be exposed in coming days, or it can also be present in the nearest reality. So in the same way, for example, someone have come across some new development in the past 10 years, in the past 50 years, someone would have been working on that technology right now. So never ever limit your concepts in AI. The emerging of AI is going very rapidly, so that we cannot catch it. In order to catch it, we have to be inside it. If you have ever seen a movie called Matrix, and if you know something called Matrix, some people say we all are living in a matrix, and we all are living in some kind of simulation. So until unless we understand our own simulation, our own matrix, our own conditioning towards this world, we never actually look into things that AI is taking forward. So leaving all these things apart, how a human can interact with a machine, how a human can make his thoughts available for a machine, is what is going to be today's concept. So let me share my screen, and let's start with a presentation of how human intelligence is connected to artificial intelligence. Now, all I'm speaking about of lot of things and high-end concepts and developments of AI brings us back to a simple biological element in our body, which is called as neuron. So this neuron have the capability of sensing things, storing data, passing the information, analyzing the information within fraction of seconds before we even recognize that is happening. So do you recognize or do you feel that you are hearing me? Do you know how my sound signals are reaching out to your ears, and from there they are going to your brain, and whatever I'm speaking in the terms of English communication, you are able to understand it. So there is a whole lot of process involved in order for you to understand, or in order for me to speak a word out of my mouth. So this signal has to be processed from the brain somewhere inside, which is basically a neuron. So one neuron will decide which word to pronounce, how to pronounce. One another neuron will decide when to speak, how to take gaps between the sentences, or how to take gaps between the words. And one neuron will say how much louder I have to speak. So the decisions are being made with the help of these neurons, or the information that I am going to speak, or the information that you are able to understand. So these things are done with the help of neurons. Now this neural activity, what is present inside our brains, have to be replicated to the machines. All right, so the process of understanding ourselves is very important in order to understand how the artificial intelligence is going to work. So now we have a lot of sensors, and we take the information from all our sensory parts to our brain, and the brain will consist of the information. It stores the information, it processes the information, it analyzes the information, it gives the response back, it gives the stimuli. We call it in biological terms the stimuli, whereas in normal we can say it as a response. All right, so and it grows based on the experiences. So once you have got a stimuli for fire, the next time you go near fire, you will be far away from it. So what is happening there? You have grown from the stimuli. You have understood that there is a bad response. You have understood that there is a bad response coming from it. So this is an understanding, or we can say the stable environment where the brain is always trying to figure out what is the possible solution for now, what is the best way to react now, what is the thing that you have to do right now. Right, people who have dependency issues, all those dependency issues will matter a lot, because the brain will continuously keep accepting those things, or come repetitively want few things that they do not actually have to do those things. All right, so we have to have the neurons in our control to understand things that happen to our body, right? So they people say, keep your mind straight, make your mindset. What does that mean? You have to train your neurons in such a way that it gives best stimuli at few best actions. Doing exercise creates stimuli, doing meditation gives you stimuli, reading books gives you stimuli, drinking alcohol gives you stimuli. So everything has its own stimuli, right? So that is the reason people tend to create their habits, people tend to do their works, do their actions, and everything the human can do is whole pointed at a single element called as neuron, which is present in our brain. So now we are going to see how this neural activity, how the functioning of neuron can be transferred or can be made understood by the machines to process the same type of information, or to replicate the process. We don't actually get the same outputs all the time, but we can try to replicate the process of how humans think, right? So from one by one, from basic points, let's say, from the point of the input, you see things, that's one point. You capture things, that one point. You store things, that another point. You analyze things, that's another point. You analyze things, that's another point. you give a response. That's the next step. That's the final step. So according to the human evolution, according to the human responsiveness, how we are gonna react for each and everything. Now let's divert back there. Right. So now these are the biological terms, how a neuron constructs, and what are the parts of the neuron where we have a thing called axon, which takes the inputs from different parts of the body and creates the information which is readable, and there is a neuron which holds the dendrites which pass the information from one neuron to another neuron. Right? It is the root connections for all the other information in your mind. So if I'm speaking something, English alone will never give you a basic understanding. If you are able to understand what I am, you already know what we are talking about, where language ABCD, will you be able to understand what I am trying to tell you? No, because that alone is not sufficient for you to understand any other concepts. So here the same thing, the English concepts will be stored in one neuron, and the understanding of the language or the understanding of the concept which is relatable to one another will be stored in one another neuron. So there has to be a connection between one point to another point. The same way it has to be replicated to machine as well. Why I am stressing all of these things is because when you start understanding, or when you try to look into technical things, you tend to confuse a lot, or you tend to deviate a lot. So you have to bring it back to these statements what I am just telling you to understand what exactly is happening there. So getting the information, storing the information, passing it to one neuron to another neuron through electrical impulse. Our brain is having a capability of charging a laptop, or more than that, much more than that, producing electricity for a house, or producing electricity for whole town, maybe in some situations. It produces a lot of electrical signals that are sufficient for a human to exist. But how is that is going to happen? It is taking a lot of inputs from resources, and it's all some psychic stuff. So now what we can see is, one second. Yes, I'm back. Okay. So what I was just trying to tell you is how a neuron takes the input and gives you the output signal. Now I will try to replicate this in forms of equations and in forms of mathematical formulas. So basically speaking, we take the input, which we call it as input variable. All right. So let's say x1, x2, x3, x4. You are listening here, you are watching up my screen, and you're trying to understand what you're connecting dots between things, all such things. So there are multiple inputs that are involved right now, and we can say all of these inputs are x1, x2, x3, x4. And now this information has to be passed to a neuron, and the output is, you are understanding these things, and you're reacting if you are having any doubts. If I tell you to open an anaconda, and if I tell you to execute something, you are trying to understand, or if you're trying to execute a formula, or you're trying to execute an equation over there. So the information what I am trying to tell you is an input for the neuron in your brain to produce some kind of project. That can be your output signal, to execute one simple function. In order to execute one line of equation, you have to have the understanding in the neuron which has been developed using the input that any master or any guide is providing, right? So now let's see. So these things, the interaction between the input signals and the storage part, that is a neurons, the between connection is called synapse. And the connection between one neuron to another neuron is called as dendrites and is done by dendrites, and we have electrical impulses over there. So for now we can say that synapse does play a vital role, because once uh, you have the possibility of altering this synapse. I'll tell you one example. So you are trying to understand a visual, all right, you're trying to understand or remember something from your past. So what your friend or what your colleague might have told you, some information or some concept regarding it, or something very really important about a thing that I have stored somewhere, or a secret that are trying to tell you. So now let's imagine they told you that I have kept my room keys in so and so place, and because I'm going to some other place, please you have to remember where it is. And they left out of town, and when they came back, they probably forgot what they have told you. Now what you are trying to do is you are trying to recall what they told and where the keys are. So now what you will do, this is an input that is present in your neuron, which has to be stored, and it should be an output as that, yeah, you told me that keys are there in your second cupboard, right? So but the thing is, even you tend to forget sometimes. There will be a data loss, there will be neural activity which is minimal sometimes. What happens here, this synapse, you are just trying to use the input and the neurons to get the output. So now what we try to do is we try to change this or understand the synapses, what is happening there. For example, if he told that uh, I'm keeping my keys in my second cupboard, where I keep all of my second job stuff, or if you can say second project stuff, or you can say second candidate, or something which is there in their hands, or second key, where second key, this is my second spare key which I am keeping in my second stuff, second shelf. So he is using some kind of other statement, or you might be having some color differences which you have particular uh, you know feature about it. So there may be one first color may be blue, second color, second shelf may be red. So now the say that day you're he's also wearing the red color shirt. So okay, you kept in the same color shelf, you took something as a reference in addition to the actual information where the keys are. So now what is happening here, in addition to the actual input, you are creating some weight or some other information added towards the actual information. So this you might not remember actually, but when you try to dig deep into it, what happened at that point of time, getting my point? So it's not just the input, but also the synapse, or also the content that is traveling along with the information, that is very important. So when the actual input is given, there will be other information as well that go into the neuron. When you're watching a movie, you have the popcorn sound, you have the friend using phone, and a lot of other things. When I am talking to you right now, you might be using your WhatsApp phone, someone may be coming, you might be having cup of coffee, you might be watching your kids moves or do something. That goes along with my speech into your brain. It's not just what I am telling you that is going into your brain. There will be other information as well that go into the neuron. When you're watching a movie, you have the popcorn sound, you have the friend using phone, and a lot of other things. When you are watching a movie, there may be a lot of other things.
Sir, Yaswanth Murthy.
Think
Sir, your voice is breaking. There's some signal problem is there, I think so. Hello?
Hello. Yes. So yeah, there is a lot of importance. So is it clear right now and clear and visible? Yes, thank you so much. And yes, that is the reason we have these kind of information. See, we do not recognize all these things in our day-to-day basis, but these actually matter a lot when it comes to machine, because it just doesn't want to take only the input. It also want to understand things very clearly how a human can understand these things. So every small detail of things that are happening over there are important for it. When you watch this robot movie Chitti, when it is doing something, when Vashikar asks something to the robot, it will go back to the memory and fetches some information which is there in mere background. It doesn't even focus at that point of time, but it will, if when it comes to recalling that memory, because it's a robot, it has a very clear cut image of what is happening in the background as well, which human tend to not focus about it, but as a machine it will tend to focus a lot of other things along with the actual thing that is happening. All right, so that is where synapse comes into picture. And next, so as how the variable things work, when now you are trying to deviate little bit towards mathematical and mathematical formulas. If you are giving your input as mathematical function which is numbers or numerical values, there are two options. It can be continuous data, which means it can be increasing like stock market, salaries, how much expenditure, taxes, and a lot of other stuff which are related to incrementing or decrementing time along with the timestamp. So now there may be other data which is yes or no, 0 or 1, which can be categorical, which can be divided, or it can be number of groups. If you can say, if I gave you the list of 100 students and their marks, now you are trying to categorize things or categorize people according to their scores. So now what is happening, there is in all of these cases the input is numerical, but you are trying to predict the stock market at some point. You are trying to divide people into few multiple groups at another point. You are trying to decide whether you have to purchase a product or not in another situation. But the input for all of these things is just a numerical values. So depending upon the use case, depending upon the input type you give, the differences between the output matters. All right. Now, yeah, this is what I was telling you about. Along with the synopsis, there will be some other information which are called as weights that will come along, which add value to the actual information. Right. Technically speaking, what happens here is the information that is present, which is called x1, will combine with the weight y1, w1, and this is passed. And it's not the only thing that is passing, right? So the English language, let's say the English language is x1, and the content that I'm speaking to you about, the neural activity, the mechanism that I'm speaking to you, that you already know, that is called as x2, and some other weight along with it, which you already have reference to in your own brain, which I am not aware of. All right, so there may be multiple things that are involved that can help you to understand one particular event. Let's say the complete thing as an event, that to listen to a lecture, or to listen to even that it is about artificial intelligence. So there involves a lot of other things and a lot of other weights. Now all of these things will be added, and now you can understand the programming of machine learning or programming of artificial intelligence. Basically, this threshold function, so inside this there will be functions in your brain. You are not aware of what is happening inside, but when you are trying to convert that into mathematical formulas, so for every particular situation, for every particular instinct, there will be one function, there will be one formula, there will be an algorithm hidden inside. So now how to understand what algorithm it is, what type it is. So now, if you have the binary equations, or binary classification, which are 0 or 1, yes or no, true or false. So what is happening here? You are taking some multiple inputs and you are categorizing things into two formats. So if the value is 1, like if the value has to be 1, then the value input value has to be at least 0 or greater than 0, or if it is less than 0, it has to be 0. So this is a simple example, but instead of x and 0, let's say if the pen is in blue color, then give the value input as 1, give the output as 1. Or if the pen is in red color, give the output as 0. Make sense? So, or else in other situations, if the person scores above 50%, make it as pass. If he scores less than 50%, make it as fail. So these are the binary situations, and the function that you use to determine these kind of limitations, so that function will be present inside your neurons. That means the neural activity which is there, we have to convert that into a form of algorithm, into a function. That function will be used to give your output. So multiple inputs will be taken, and input will be passed into a neuron, which is basically a function, a mathematical function, and this will be taken back to the output. So if you can see here, 0 or 1. So there are a lot of other things based on different situations. This is 0 and 1. This is incremental sigmoid function. This is also something of 0 or 1. And for whatever the situation you have, sometimes this is like a triggering for your human activity. So when you are already in anger, so whatever any person tells you, you react in a very different form. Then the same thing if he tells you once you are cool, then you react in some other way. So it's like for any information that is given, it will take the point to a maximum instinct or maximum data points. The given a data source of 10 points, it will always choose to prefer maximum amount in it. So something like this. All right. So now these are both two extremes, 1 and -1. Here what we saw is 0 to 1, the both situations, and now here it is -1 to +1. So there may be situations where you went to a coffee shop and you tend to order something. So now you're trying to check back to your bank account. So you are hungry and you didn't care, and you're trying to eat and eat and eat, and you're along with your friends, and even they didn't care much. So what is happening here? Until it is here, it's fine. So now suddenly you found out that you don't have any money in your wallet. So now what happens? The graph will come to -1. Yeah, we can't pay it. Okay. So now suddenly someone calls you and tells, bro, I have to give you 1,000 rupees. Just I'm sending you right away. Now it goes back to plus. So depending upon the situation that is being present, the situations will come to go according to your thing or not according to your thing. Taking that in a mathematical format, mathematical perspective, that we call it as -1 and +1, both two extremes of the data points, both two extremes of the output points. So this way you have to communicate to your algorithms the way you think has to be converted back to any algorithm in some situations. When you're taking a decision, you will choose some things. You will have some idea about what you're choosing. What is the output that you are expecting? What is the input that you already have? Whether the input is numerical, whether the input is categorical, whether the input is mixed data, whether the input is something according to your senses. So what is the type of input that you are getting, and what can be the algorithm that is applied to? So now whatever I am speaking is about numerics and few things, and within a few minutes we'll look back to things, how to do with images, how to deal with audios, how to deal with other senses that can be performed. All right. So now you have a clear understanding, or if you have one vague understanding of what happens inside a neuron and how the input and function and output can actually work inside a artificial neural network. All right. So now there is one other concept called backward propagation. You went to fire, you touched fire, you got a response, you took your hand back. All right. So here what is happening here is, you have some outputs already. So now for every kind of input, the input will be the process will be traced back to the input value. Same like the keys example. So you went here, the output is not found, the keys are not found. So now you are going back and checking the synapses. Now you are checking your weights. Now you are checking back your inputs. What did you tell me? Person one, like he's asking person two, bro, what did you tell me? You just have to try to remember where I did place my keys. I have to find them. I have to use my car now. So please try to remember where my keys are. So he is trying the back propagation method, going back to the input what he has told, refunctioning the thoughts that he already have. So the same thing that will happen over here from the output value. So we do have an actual value which we are not aware of, which we forgot. They are there in second shelf. That is the actual value, but we forgot. We are seeing the output value null. So we are not able to remember where the keys are. So now what you will do, you tend to look back. In this case, in the keys example, you and me both are people who doesn't know what the actual value is. We are trying to figure out, but when it comes to the machine, it knows what the actual value is it? It knows where the thing is stored. And just a second. So it does have a record of the actual value. So now what it can do, same as the machine learning example what we spoke yesterday, it checks the predicted value to the actual value. Same as that, it has the actual value and it tries to check what the output has been according to this function. So now the back propagation will help until it reaches to a certain limit. So these are the examples. So what is happening here is you have multiple examples of students from their study hours and their sleeping hours and their quiz mode. So based on this all the inputs, we are trying to figure out their possible examination scores, and we do also have their examination scores. And now we are trying to figure out the pattern, how an artificial intelligence can predict these things by adjusting their weights. So now, why do we do all these things? Why do we have to adjust these weights? Because when you forgot where the keys are, you are trying to get a reference from some other information along with the actual input. In the same way here, the inputs that are actually there will tend to change the weights in a mathematical formats or in its own mathematical ways to produce the accurate results, because they do know what the actual score is. They do know what the person has achieved, the score the person has achieved in the examination, but it is trying to figure out an automated process when, if any other new input is given, it should not fail to recognize the score of the person or the student. So if it performs well on the existing data, if it understands the existing data well, then it can probably, or it can most probably predict the new coming data as well. Correct. So now it will try to run this back propagation multiple times until it achieves the stable state or the maximum accuracy, which means we already have the actual value stored, and we do send the inputs and we will try to figure out the output value for it. So this process will go, for every user, for every unique user, there will be one unique neuron getting triggered or getting trained. Okay, this is a simple example. This is a elaborated granular example, but actually this will not work in this distributed format. There will not be this many neurons. So the neuron activity will be like this. So the inputs are gonna go into the model all at the same time, but for one specific set of inputs, there will be one specific set of neurons activated. For example, if we take this first input layer in the first row in it, so this particular block or this particular cell is connected to one few different neurons, and it is again connected to only few other neurons. This again in this hidden layer 2, these will be connected to few other neurons. So the information that has been passed, okay, what is it? Let me, okay, I guess it is in another slide. All right. So we are here. So that is the reason, these weights have this importance in understanding a neural network. That is the reason I started explaining to you in the first step. All right. So now you got an understanding how your input value goes, how back propagation works, what is the importance of the weight, what that means the reference that has taken along with the input, then the function, then the output, then the actual value, then the accuracy. They'll check the input and the actual value, and they'll trace back to maximum performance. Once you have got a maximum performance, then you are ready to get the testing ready. Like you can predict few things, you can take its decisions automatically, it can have its own intelligence, it can produce the results by itself without even looking the actual data. If the accuracy is more than 95 to 99%, we can rely on that artificial intelligence system stating that it now has the ability to have its own decisions given these many parameters, or given in this condition, given in this scenario. We can say this robot gives us the best results. Okay, now yeah, these things are too. Okay, so let me tell you one simple example of stochastic gradient and what happens to the errors over here, how this error thing works. Once at one point of time, when the error rate is let's say certain point, next after a few other training sessions, it got a few other neural activities, it got another activity, it get trained again, the function has been replicated again, the input has been given again, the more input has been given again, so it undergoes the training again and again and again. We call that as epochs. That means you will have only 100 inputs and there will be only one function, but those 100 inputs will pass that function again and again and again. That the movement of the same inputs and the same function multiple times, we call that as epochs. Okay, for one epoch, okay, there may be one particular error occurred. For the next time it is getting trained, for the next time it is checking the accuracy, the error may be some other point. For the next time it is getting trained, the error may be some other point. And there comes one stable state. Beyond that, the error is not getting decreased. It can increase by the increase of epochs, but it is not decreasing below that. So now under those circumstances, it will decide that this is the best possible solution, this is the best possible outcome, so it will stop there, it will stop its learning there, and it will start predicting things. Got it? So what is happening here, it is just trying to train again and again. How, if you are going for boxing or if you're going for any kind of sport, do you have the accuracy of performance in the first go? No, you're gonna get trained again daily. Daily morning you have to get up, you have to go, you have to get trained again and again and again. Then after a few days you're going to achieve a point where you're not going to do any mistakes. So in the same way, this training will be called as epochs. For each and every epoch, the error changes and it will check the accuracy, it will check the errors again and again. So yesterday someone asked me whether we can do the regression in artificial intelligence or neural networks. So what is happening here is, for every epoch, there is one complete linear regression happening, and again for the next epoch, there is again one complete neural linear regression happening for multiple inputs, not just one time. There we are only having one data, we are only having one function, we are only having simple data. But here we have huge amount of data working on the same model and having the approximity of maximum number of outputs. Now the repetitive function that is happening here will tell you to rely on that accuracy. All right, so if you can say, if you can take this as a 3D dimension of your errors. Now for some epochs there may be, this can be the error. For some epochs there the error can be like this. For some epochs there can be error over here. So if you try to plot a graph about all the errors, so there will be some point where it can be having the minimal errors. Now as simple as that, take a cup and or take a paper, just leave a ball or leave a small round color thing in there, and it will move back and forth and it will try to stop at one point. All right, so that is a minimum error point. Like this, it will go from here to there, and yeah. So now I think you got the point. So now over here, wherever the ball stops without any further movement, that is called is your best probable output. So you don't have to know about all the other technical things that are there, but yeah, these things are enough. These are the examples of how things work. As I told, taking the input x1, adding, multiplying with w1, then adding the next input x1 into w1 plus x2 into w2 plus x3 into w3. This is how it gets its input added, it gets its function stored, right, and it gets its function activated, and then it goes for the output value, right? So now let's see how these things matter when it comes to images. Let's have the complete practical session as well. So before moving into practical, I assume that you have installed Anaconda. If you do not have installed Anaconda, you can start now. You can keep the Anaconda downloaded now, so that in next 10 to 15 minutes it can get downloaded and it can get installed. But if you do get downloaded and if you are ready for any practical sessions, that's great. And for the people who are not ready with Anaconda, please I request you to start downloading it. If you need any link or something like that. So I'm pasting it in the chat. For those of you who do not have Anaconda install, please, and let me go back to so I guess you have understood the neural activity and how the functions works, how the replication of your human thoughts can be done for any mechanism inside a machine by giving the numerical inputs, training the functions again and again, and checking with the actual outputs and back propagation and all such things. This is a core capacity or core functioning of a neural network. This can be incremented to multiple levels, like for image recognition, for speech recognition, for computer vision, for video analysis, for a lot of other things. This is a basis. If you're try to change the functionality, the way it understands changes. If you're trying to change the input functionality, it will try to change the output values. If you're trying to change the pattern of weights, the output changes. If you're trying to change anything inside this neural network, the output changes. Right? So for every specific condition, for every specific situation of the function or sigmoid functions, linear functions, for every function, there is one possible output. So now, depending upon the use case that you have, so these things which I spoke yesterday, you have to relate to those concepts. So before you start doing any project, there are a few steps that has to be involved. So you have to understand the use case. You have to understand the possible output that is required for your particular use case. So now that you have understood the use case, you have to decide which kind of function has to be used in the place of a neuron, because your brain, you don't have to tell to it has its own functions, it will run on its own. But for a machine, you have to specifically mention what is the input, how many inputs are there, what is the function you have to use, what is the output expected, how many outputs are expected, how many hidden layers are required, how many times you have to get trained, what should be the accuracy. So these are the things that you have to mention clearly to the machine in order for it to understand one concept. All right, so let's now see how any convolution neural network works. So now we can say now we are moving a little bit forward into the neural network activities where you have understood the basic picture, but this application, how it is gonna get used in images. Okay. Now, given this image, you have to just guess what is there here. It's a lion, it's a leopard, it's a cheetah, whatever it is. So we humans tend to understand by looking at the, we know, we can recognize. So it has some colors, it has some black dots, it has some yellow orange kind of color pattern. It has a fearful facial structure, all such things. This will give us an impression of this is a leopard or cheetah or cat. So now we are able to distinguish this. Just now I have mentioned few specifications for the cheetah. The same way, you have to make the system also understand these unique specifications. I'm telling you unique specifications. So in order to recognize you as you have some unique specifications as your facial structure, your size of nose, your angle, your smiling conditions, your size of cheeks, the level of eyebrows, the eye structure, the eye color, the eyebrow size, the forehead limitations, the ear, like all of these things, into into a minimum level have to be treated as the maximum effort. Each and every pixel or each and every unit of your face is important for a algorithm to understand that it's you. Okay, so now we can see, this is a bullet train, this is a hand glass, and such things. You're moving forward to how a neural network, convolutional neural network. Convolution means it is going to be a dispersed neural network. All right. So happy face, sad face, simple example. Now, if you take any image, yesterday, day before yesterday, someone mentioned for one image, now people are extracting it into different layers. One can be black and white. Okay. Okay. So the cheetah example that I have told you, in case my slide wasn't getting shared. So this is a cheetah example, and you have to. So now the 7 layers that they were talking about is how you're gonna divide one particular image into different layers. It's just like pulling things out of one image. One can be black and white image, one can be your background image, one can be your textures, one can be your just the people. Nowadays AI is getting so involved that you have filters in your phone, Snapchat filters, Instagram filters, mobile AI filters. How do you think those things are working? It's just this kind of concepts. Just that here you are extracting it, in your applications it is adding it, that's all. So it is recognizing few things, and it is recognizing your facial structure, your background color. It is able to change your background color. Even in Zoom and Google Meet, I have your, I think you have an option called changing your background and things. How it is happening is, it is identifying how the level of a person, how much the person is there, and remaining rest of the part, it is getting blurred. You can replace the image in your background, right? So how it is going to happen? It is going to happen in this way, which is dividing things into pixels. So now if you have a black and white image, that is so easy for the algorithm to understand, because it only have two values, black or white, maybe gray in between, right? A semi structure between black and white. But when you have the colored image, you have RGB and the combinations of RGB, right? So that is stored in some kind of 3D array. And when you have a black and white image, it is stored in a 2D format with only two values, 0 or 1. 0 can be black and 1 can be white, or reverse. Okay, so in this way, in between 0 to 1, the data will be stored. But when it comes to colored image, it has to be 0 to 1 in multiple situations. It cannot be 0 to 1, it has to be 0 to 255. So it has to be stored in all of these values. Right. So according to the color condition, according to the storage, according to the level of the photo, whether it is a face, it is a background, it is just the texture, it is just the colors, it is just the outline, or you can say the outline of the human, or outline of the object that is present in the photo, or the liveliness, the focus. So there are a lot of other things which, I'm not a photographer and all, I cannot possibly tell you the things that are actually present. There is a due, saturation. When you try to edit your photo, you have a lot of other things that you can edit. So each and everything can be extracted from the photo and changed, manipulated. You have all these facial like photo frauds right now. You have already come across these kind of concepts. So how do they do all these things? Is using this kind of neural networks, using these kind of things. There are a lot of positivities and negativities towards one single concept. But basically speaking, this is how it can get distributed. Now this is a simple image. Let's say this is a happy face image on the left hand side. So now I want to convert this into a pixel format. I want to store this into your data. This is a black and white image, as simple as that. So I'm dividing it into two different pixel formats. So this dot will get, this left eye will get stored in this box, this will get stored in this box, this nose will get stored in here, and the smile will get stored in these boxes. So wherever the black mark is present, wherever it is getting recognized, the value will be 1 1 1 1 1 1 1 1 1. So all the remaining places, it will just be 0. So this input will be given like this. Let me show you where it is. I think it has to be there somewhere. Okay, never mind. So for doing so, for making this, in this is our matrix now. This is our image matrix. Now the photo has been converted into numerics, 0 and 1. Now it is ready for the algorithm to understand. Now it is okay for any algorithms to take this input and convert this back to, use a function on it. You apply some functions on it, use this data however it wants. For doing this kind of image processing and all this convolutional neural activity, we have few steps followed. So the first step can be called as convolution. Second step is max pooling. Third step is flattering. And then the fourth step is full connecting. Let's see what are these things one by one. So what happens at the convolutional layer is it will try to create feature maps. See, it's like the first set of blocks. The first set of blocks will be taken into consideration, and one average or one particular amount will be taken out of it. It can be the maximum value, it can be the minimum value, it can be the average of things, it can be the diagonal inputs, it can be the complete sum, It can be the row sum, it can be the column sum, it can be the squares of the diagonal matrices, it can be the squares, or it can be triples, or whatever you have decided for an algorithms to understand. So here, whatever is happening, let's assume and why how that will happen is by using one filter, right? So now we will use one filter. All right, we will use one filter to multiply that filter with the actual image to produce some these kind of results. Okay, so these results, there are not just additions or subtractions of the input image. There will be one filter in between which will determine what should be the relation between the input and the output. As I told you, it can be addition or subtraction, or squares as well, or any other any other mathematical formula. Depending upon this matrix, depending upon this filter, we will decide what kind of functionality has to be used on the input image to produce certain kind of output, right? So now this we call it as feature map. This is what actually can be considered as features. This is not a feature, this is just a raw data. So now we are converting this raw data into feature using one filter. Okay, so now these features will be mapped, and this will create one complete structure of feature maps, which is called as convolutional layer, right? So this is just for a simple image, right? This is very simple image. Now let's say if you are having a very large image and you have to make sure that it is getting recognized, it will get stored. Every feature map will get stored in every single layer. And one more thing, you have multiple filters, not one. Why? Because these are the weights for the algorithm. All right, so for every possible filter, it will check its possible output. See, so for every possible filter, you will have one possible output, one possible feature map. So it will be mapped for each and everything. One possible input layer using one filter, one feature map. Same input layer, another filter, another map. Same input layer, another filter, another map. So all of these maps will additionally constitute of a convolutional layer, right? So now let's say you are multiplying with one type of filter, the image is blurred. You are multiplying one type of filter, image is enhanced, edges are enhanced, only the outline is getting displayed. You are multiplying with one other filter, it is getting embossed, it's like thickened, the contract has been increased. Getting the point? This is just a image, this is just a normal Taj Mahal image. I think this is not, yeah, okay. So now if the image is like this, if you are multiplying with certain kind of filter, certain kind of matrix, you can see the image has been blurred. So what is happening here? It is trying to store all the possibilities of the image and trying to understand the image very clearly by changing its color, by changing its texture, by changing its contrast, by enhancing it, by changing its edges, by only noticing the edges. So now I think you got the picture where why the filter has to be used. So for every possible filter, there will be one feature map, and a lot of feature maps combined together called as convolutional layer. So now this convolutional layer will fetch the important parts of the image, not all the parts, only the important parts of the image. Next, what happens is max pooling. So out of all these things, right, the only maximum structure will be taken into consideration. See, in this matrix, the 2 is the maximum part, which is having the highest amount of value inside it. Why we have to do it is because you have something like this, right? Let's say okay, let's take this part. Okay, in this part, maybe there is something over here. Maybe there is over here something, but only this part will be represented with numbers, right? Even though it is miscalculated, like, okay, saw some colors. Yeah. Maybe this will also consist of some numbers. Knowingly or unknowingly, if this white space is having number 1, or if it is having some number 1, it will have the number 2 or 3 over here. Is it? So the data which has been stored for this is 1, because it is also a color, right? It is also having some kind of weightage, it is also having some kind of texture, it is also having some kind of information inside it. So whatever the data it has, the information, it will get stored. So now it will be 1 over here, but here there is something abnormal than that. So the information over here is 2. So now what is important here, 1 or 2? Only 2 is important for now. So this will be pooled, which this will be noticed. Just how humans will focus only on things that matter, we are also looking matter here. We are training the algorithm to look into things that actually matter. We do not want the sky over here, even though it is having blue color, even though the birds are flowing there, even though sometimes there may be images of trees over there. Even that is a information, even that will be stored over there, but we do not want it. We want some kind of uh, thing that is having higher weightage. So now this will get understood. Remember, what if you have some other thing, you will be having a lot of other doubts and a lot of other things that are blowing up in your mind, but this is not the one time process. This same process will get repeated at hundreds of times. So now what happens, hundreds of times, thousands of times, if the same thing is getting triggered again and again and again, if there is 2 here 1,000 times, now you will understand that the top one which is there in blue color, the sky is not important. Even though you have tree there, even though if you have a bird flying over there, that is not important. The structure, what the monument over there is important than the bird over there. So this information, this understanding will be given to the machine over this epochs, over these multiple types of repetitions. Okay, so next what happens, you are trying to fetch the important parts out of it, you are trying to figure out the maximum portion of the image, and you will try to understand it. So from the input image, you have got some convolutional layers. From convolutional layers, you have some important questions here, like you can say important questions, the important information. The best possible example for it is handwritten recognition and such things. So now you will flatten these images. So any algorithm will not understand matrix for sure. There are some functions per matrix, but basically speaking, all the mechanisms will work under array formats. Even though if it is a matrix, even though we have functions for matrix, the algorithms will work very profoundly only under the array circumstances. So now what we have to do, we have to flatten these complete pooling arrays, pooling matrices. So 140 140 122 122. So we have to yeah, sorry, 110 110 421, again 421 021 021. So this is an example how flattening works. And the same way, the complete image will be represented in a array format and then given back to the neural. This is the actual input layer for neural network. So whatever we have done till now is not the input layer. Whatever we have done till now is we have arranged, we have manipulated the data, we have understood the data, we have done some basic data operations, but not the actual input. So now we have the actual input layer for the neural network, which we have seen in the previous slides, previous presentation. So this is an actual image input, which will undergo a lot of changes. It will have convert back into convolution, it will convert back into pooling, it will extract the important features, it will convert it into an array format. Even in the machine learning, we are converting the data frame into an array. Even here we are converting the pooled layers into the array formats, or the flattening formats. So now after flattening, the inputs will be given as x1, x2, all the things that are being in the array format, those things will be given as a data points for the nodes, as data nodes, right? These are called as data nodes. These each and everything over here is called as data node. Data node 1, data node 2, data node 3. And there will be fully connected layers in the sense each and every node is connected to each and every node inside the hidden layer. This is an input layer, this is an output layer, these are the hidden layers. Okay, so data will be connected from input layer to output layer via hidden layers. So these hidden layers will have the functions, sigmoid functions, or the calculations that you are supposed to do, all the understanding that is been involved in this artificial neural network will be stored hidden inside. You will not be able to access those things. You can using some advanced packages, but in general you will not be exposed to these kind of hidden layers as simply as input and output layers. Okay, so input and output layers will be in your understanding, in your human understanding, in our human understanding. We are responsible for input layer, we are responsible for output layer, right? So hidden layers will have the sigmoid, the functions that are responsible for the understanding. So now the data has been given. There can be multiple hidden layers. We can choose how many hidden layers to perform. We can choose how many layers to get involved while doing all these activities. So this is the presentation I wanted you to show. So we have what we have here. We have a dog image and we have a cat image. So there are multiple images, not one or two, but we are giving this image as an input. So this will undergo convolution layers, it will undergo flattening, this will undergo max pooling, and the one array or the array nodes will be created. So that array will be given as an input node. And from the input node, it will go for hidden layers. The sigmoid function will work. It will produce the output. Before it predicts that it has a dog or cat, the process of neural networks works. We already have some examples of dogs. We already have some inputs of cats. So now it will check the input and output value for accuracies, and it will come back in drop propagation over here. So once the input is done, it will the activities that are happening over here, the impulse that will go from input layer to hidden layer, and hidden layer to output layer, and again it will come back to the input layer if it is right or wrong. It will check back, if the accuracy is wrong, if the actual data is not the perfect answer, it will go back and it will adjust the weights. It will adjust weights in such a way that until it recognizes the dog image as dog, it will keep changing the weights. All right, so we have some weights in between, we have some synopsis and all those things. We have this is how we represent. So this is like, once you have to reach some destination, you have to reach from input layer to this dog destination. If you go in one particular path, you will have the maximum, you will go in a very much faster way. This is a shortcut for it. But if you tend to choose some other paths, which is 0.2 or 0.1, which is not the actual path for dog, so then if for given image dog, this 0.1 and 0.2 will not work, because these are the weights related to cat when given image is dog. When given image is cat, here it will be 0.9, here it will be 0.8, here it will be 0, here it will be 0.1. That means the proportions will be opposite. Got it? Here there are only two examples, dog or cat, so we can understand the proportion distribution. When it comes to multiple images, when it comes to multiple categories, multiple output possibilities, this is not how it works. The input layer, the things in between the input layer and hidden layer are so suspicious, where it's not just about 0.9 or 1 or 0.2. It will have very high numerical understanding, very few mathematical implementations. This is where the complete understanding of the formula has to take place, and then you'll have your output shown. Got the point? So now let's see how we can uh, get back to the practicals. All right, so I hope you have got a very good understanding of a neural network, and how a data is processed from input layer to the output layer, how a image will be processed, undergoing a lot of changes, and how the actual data has been given instead of raw data as an image, how the image will be converted into arrays or nodes, and how the numericals are being given for the hidden layer or for the algorithm to perform some calculations and to predict what kind of image it is, or to predict some kind of output. Got it? So if these things are clear, and if you have any more doubts regarding this, you are free to ask for the next 5 minutes.
Excuse me, sir.
Hello.
Hello. Sir, can you hear me?
Yeah. Please go ahead.
Can we have more than one hidden layer in this?
We do. We can have. Yes, we do. We have more than one hidden layer. It is just an example. So we have multiple hidden layers, of course. You want to have more accuracy, bring more hidden layers.
Okay, sir. Okay.
Okay, if these things are clear, let's take a 5 minutes break, and we'll come back to practicals. I hope everyone are ready with their anaconda. Let's start with where we left out yesterday, and let's see that we can execute everyone can execute linear regression, and let's see a few more examples of regressions, and we'll come back to executing the neural networks as well. Okay. practices, right? So I hope you all have anacondas and Jupiters ready for the executions. Let me share with you a few more things before that. So once you are ready with your anaconda or Jupiter, you have to be able to set the paths, which is very important before doing that. If you are not aware of those things, please take a note where setting up a path is very important in Python and Anaconda's environments, where you should not lose track of your paths, and it will assign Anaconda. It will connect Anaconda to the Python environments installed in your laptop. You have to install Python as well and Anaconda as well for all of these things to work out. And you have something called pip install for installing all the packages that are essential to execute any kind of model. Or basic examples of CNNs, right? Or we can say artificial neural networks. Let's take one example. Yeah, sure. So where exactly are you there in pip install? Let's do one thing. Just let me share you. Can see. So I'm expecting that, hoping everyone are there in this screen or in this page. If you want to install any new package, you have to put exclamatory mark if it is Jupyter Notebook, or if you're using Spider, or if you're using any kind of IDEs, you do not have to use this. You install pandas and execute. Okay, this way you can bring your packages into your kernel. You have your kernel here. You have your kernel here. So whatever you do is gonna get reflected in your kernel, Python 3 kernel. If you can bring it here, you can see the kernel idle. Right, when you say now it is kernel busy. So when it is executing something, the kernel will be busy. That means it is trying to get this pandas package into your kernel. So now it is ready for your execution. For example, let's say data frame is equals to pd dot. Okay. We have to import import pandas as pd. This is alias. You have the pandas package in your kernel now, right? It is there in your local drive. Now you have to bring this to the Python usage. You have to bring this to your programming now. So now you are importing the package into your program and you're using this now. So now data frame is equals to pd dot. If you press tab, you will have all the possible functions that are present inside the pandas. So whoever is trying to explore machine learning, whoever is trying to explore artificial intelligence, this is a very good access for you guys to start learning about this. You can see multiple variations of the components present here: APIs, arrays, date range, Boolean types, categorical dates, category indexes, concatenation, uh, cross tabulations. You can cut the data, the data frame, data range, data offset, errors, Excel files, writing to Excel files, right? You can get the dummy data of the present data. You can slice the indexes, you can check the indexes, you can uh, do multiple things over here, right? Interval range, right? You can check the null values, all the data operations. So you just have to understand which package to use or which function to use, which of these to select: q-cut, quartile cuttings, pivot table. If you're familiar with Excel and all, you might have already known what a pivot table is, how to create a pivot and all. Read CSV. Now we are going to use this read CSV, and we are going to take. Okay, so let's say the Excel file. Where is this file located? I'm really sorry. Or let's say we are from here. So we have to set a path right now. Okay. So this is very important because you don't have to go and look out into paths. I do not do this generally because I always make sure whatever files I'm working on are in the same folder or in the same path that can be arranged. So now I have used one of the package from pandas to get the data. Okay, so in this manner you can keep exploring things and try to utilize the packages that are given inside the pandas or inside any of the packages of Python. Right, so we'll go back to our thing. Hope you can follow me, and if you have any other questions or doubts, let's take it in the end of the session. Now let's look at a multiple linear regression. Yesterday we have seen how a linear regression works, but this is not much different about it. We have multiple rows now. All right, so as you can see, the same data, 50 startup data. We have R&D spent, the money spent on research and development, the money spent on administration, the money spent on marketing, according to the state. All right, so state is a reference. You can group things according to state. You can compare the expenditure according to states, and you can have the profit analysis. You can have the spend analysis. Everything. This is one important parameter that has to be involved in understanding the other expenditures. So this is a categorical value, and these are the numerical values. So using these kind of things, using these differences, it is very important to make sure So now we have seen x is equals to, you have dividing your values into x and y. What actually differs is the algorithm that you are going to use. See, all the things which are using here, the label encoding. Okay, yeah. So we are gonna speak about one more thing over here, which is called as label encoding. So guys, until now we haven't come across this concept, but now as we have a new thing called as categorical variant, we have something called as state over here. Right? Let me open the Excel file as well. Right. So in Excel file we have how many values? We have three: California, Florida, and New York. We have three categorical values. Now so we have three categorical values and we want to convert that into numerics. We do not want to give the categories as input. The important thing is no algorithm can understand anything in textual format. It only can understand numerics, numbers, only numbers, mathematics. So the core element of any of this artificial intelligence are numbers, mathematics. So you have to convert all the things into numerics and mathematics format. Even though if it is categorical, you have to mention it as categorical, but it has to be in the numerical format. See, now I'm trying to convert these three things into numerical ways, which means I am trying to convert, or I'm trying to label those things. I am trying to give a name for it. Let's say 0, 1, 2. All right. So now for what is gonna be there, how can we check it? Insert 2 is there, 2 for New York, 1 for California, 0 for Florida. Yeah, 0 for California, 1 for Florida. So it will be in alphabetical order. So California comes first, so C 0, next F for 1, and then New York 2. In this way, we can label these things. You can see here 0, 1, 2. All right. Now the data has to be split. So this manipulation has to be done before you split the data, basically. So once you are good with this splitting, then good with this label encoding, then you will go for splitting, data splitting, X and Y, the independent and dependent variable splitting. So now once you have this independent and dependent variables with your hand, in your hand, you will go for data understanding. Right. So now you're gonna split the data, training and testing, and you're gonna use it for your modeling. So here you have your images where you can check how the data is represented, how the data is evolved from one state to another state. See, 0, 1, 2. In California, these are the data points. In Florida, these are the data points. In New York, these are the data points. So this understanding has to be there for you and for the computer as well. So now if you want to trace back it to the elements, you can always use the inverse function. When you have converted to, let me show you that as well. You have fit transform. You have used the transformation. You have transformed this categorical values into numerical values using fit transform. You can always inverse transform these 201 back to the numerical formats about the input or the output you get. All right. As how it is there as fit transform, you also have. Okay, I think I didn't execute it. Oh yeah, it is then yeah. So there is fit transform, inverse transform. So once you go for inverse transform, what the picture? So it is used for transferring the categorical values into numerical, numerical values into categorical back when it is required. Now let's see how that model works. Now we have multiple values, but we only use thing called as linear regression. Linear regression, once you call the linear regression, even though if we have multiple inputs, that these are the multiple inputs. These multiple inputs will be taken into consideration into train value, and they will be predicted as well. So now we are fitting the extrain values. What are the extrain values here? So these are the values. You have R&D, you have some more things, and you have the state. And now when you're predicting it, so for the test data, so here using X test, and we are giving the results of Y predict. Even though you have multiple values, you are able to predict your data. Now you can add up your accuracies as how we have discussed yesterday, but I'm not gonna go there and show you all the accuracies for now, because it's a thing that you can follow up again. And coming back to polynomial regression stands in a very different perspective, where the data distribution will be it will be very exponential in manner, and it will give you, it will not be as general as the multiple regression, or you can see here the data is been can you understand the data flow of the red points over here? So the data flow of red points is going exponentially. It is going beyond a normality. Excuse me, can you someone is able to control the screen? Please take care of it. So yeah, this red points are going in an exponential format, which is not normal along according to this multiple linear regression or normal regression. Okay, so the same thing, the same data will be same, the functionality will be same, data splitting will be same, the label encoding will be same. The only difference that you have to face is the model, how the model encloses these things. Right, even here you're going to use linear regression, but the functionality that is going to take, you're going to give the polynomial values to the function. So basically these all the three regressions work in the same way, just the input that we are going to give is different, the output that it's going to understand is, the way it understands is different. For linear regression you have only one value, for multiple linear regression you have multiple values, for polynomial regression you have exponential data values, data points, right? So now let's see about decision tree. So decision tree is a function which is used when we have multiple conditions, basically. So we have multiple conditions to choose, we have multiple conditions to perform and analyze. So now what happens is, let me execute and show it to you. We have a decision tree classification, decision tree regression. So any algorithm you take, it can be done in two ways. It can be a regressor, and it can be a classification also. Why? Because if the data points are going to match a few ranges. All right. So instead of saying 0 to 0 or 1, I can say 0 to 1. The output is same. It's either 0 or 1. But in case of regression, it will take 0 to 1. In case of classification, it will take 0 or 1. Only two ways, only 2 points. Sigmoid function will be used to determine the classification, and the regression functions will be used to determine the regression. So decision tree regression, support vector machine regression or classification, KNN regression, KNN classification. So all the things will have both the sides. It can classify things or it can predict things. It can do the regression as well. So now we are looking at decision tree regression. Because you have multiple conditions over here. Now, if you can look at the data over here, there is one possible output for one possible condition. It is not linear as well. It is not it is polynomial, but we are using decision tree to take control of the output present. And what will decision tree do? It has multiple if else conditions. Let's say for one condition, okay, let me give you a visual example. So yeah, so it will check the conditions. If the data is less than 5, if it is, yeah, if the x is, if one value is less than 5, and then again to check for one more condition, if y also is less than 2 or something, then the output is 1 or else it's 0. So it will have these kind of tree structures, decision tree trees basically. So for every possible condition, if it is less than 5, greater than 5, greater than 20, less than 20, greater than 20. So this is just an example of how a decision tree can be built. But when it comes to huge amount of data, you have multiple nodes, you have multiple data points like this, and then you will have your output somewhere around over here. So when you see over here, this is a probably a distribution of decision tree regression, where you can see the ranges, right? You can see blue and green over here. You can see only green over here. You can see blue and green. You can see green and blue. So there is a combination of data. So the 83% it is 5, and only a very small percent it is 1. The output is 1. 100% it is 15. 83% 20. So here there is a range involved in deciding things. Instead of just showing 0 or 1, you have a range of values that are involved. So now this can be called as regression. So whenever the continuous data is involved, that is called regression. Whenever the differentiation, only extremes of data are involved, that is called classification. So now what we are using is decision tree. We are giving the authority for the decision, to check condition by condition, for one condition to another condition, and decide the output now. Okay, so now this involves, we can from sklearn dot tree import decision tree regression, and we are fitting the decision tree regression. We are storing the decision tree regressor into one variable called regressor, and we are fitting the data x and y into the regressor, and we are predicting the values. We are giving the years of experience, and we are predicting the salary. So this, the same value which has been done using regressor or a normal regressor can be done in decision tree as well. But this accuracy is different. This hits different. The use case hits different. The why we use decision tree is when you have multiple use cases, multiple scenarios in one particular problem statement, multiple conditions. We do not know on which condition what is the output, then these things will help. Next comes random forest. This random forest is a group of decision trees. Basically, decision tree is nothing but if else statement. If you can make it as simple as that. So a group of conditions, a group of if statements, a group of range conditions is called a decision tree, and then a group of decision trees is called as random forest. It has a variety of possibilities. It will check, making every possible condition as a leaf node. So you are aware of a tree conditions, right? So a leaf node, a parent node, and all such things. So here each and every condition will probably become a leaf node, and each and every condition will probably become a parent node, and then it will check all the possibilities, just like artificial neural networks. Just like this is not an artificial neural network, this is not at all a neural network, this is just a condition that has been observed using the data. So now what is the difference between these things? Only the difference is you're gonna call random forest regression, and the estimations are 1,000. You can check into the parameters and you can understand why these are given and all. So there are these many parameters which I cannot keep mentioning all things about. So we have to call the random forest regression, and we have to fit the data and predict the data. So here comes the end of naive machine learning things. Like until here, until random forest and until supervised, unsupervised, all these learnings have only one difference, is that the package you use, the data format you give, the output you expect. So apart from this, all the algorithms are almost same, and you can understand these things in execution part very easily. So now going back to neural networks, just a second. Okay. So let's see about how things are done in neural network paths. I'll show you the basic example for now, and what are the steps involved. As same as how a machine learning model works, the steps are gonna be same. The part inside the functionality, so the X data, the training data, the value that decides X value, independent value, dependent value, that are same. So you have to check, you have to manipulate the data, you have to check for the data cleaning has to be done, label encoding has to be done. Data has to be transformed to one or the other format if it is required. And one more another thing is one hot encoding. Right, here comes one hot encoding where the complete information, whatever is there. See, there are 700, 0, 1, and 4000 something, like a lot of ununiform data. So what one hot encoding does is it will convert all the data into its simplest data points. 1.000. It just takes all the values into one uniform format, and it is also like label encoding. It is also covers the actual data with one more alias names, but only the algorithm can understand, only the given data can understand the importance of these things. So by seeing this, no one can actually tell what the data is, but only the algorithm, only the one hot encoder can understand what is its actual data, what is the data given inside this. So now again the training test splitting is to be done. As I was telling you yesterday, there are few feature extraction techniques that has to be done in order to perform some operations. One of it is standard scalar. It will bring back all the elements into one standard format, and it will allow the algorithm to look at things in a unique, or in a similar format. It doesn't want to understand 700 in one format, and it doesn't want to understand 10,000 in one other format, and everything has to be uniform in order to algorithm to understand something. Like I do not have time to explain the functionality and all of those things, but yeah. So this will create a similarity between the data. This will create one standard mechanism for any algorithms to understand. All right. So next, going back to things. First of all, you have to import the libraries. Then you have to initialize the neural network. All right. How do you initialize the neural network? Is by calling something called as sequential. Sequential is a name given for creating a network, creating a neural network. So from out of nowhere, Python has to have the capability of making this complete neural network, empty neural network structure. As we have seen the image of this dog example in the end of the slides. All right, so we have the empty neural network constructed when you call sequential. Where does it stand? This is there in the models package, which is there in Keras. Keras is widely used deep learning package, and this has Keras and TensorFlow. So Keras and TensorFlow are widely used deep learning packages. Use it for these kind of high-end AI operations. All right. So we have to start creating network layer. Someone have asked me how you can use more than one hidden layer. So we call it as dense layers. Once you enter into forest, there are multiple layers and layers and layers of trees that are coming in front of you. So we call it as dense forest. So here also they have mentioned the name as dense, which means you can keep adding the number of layers, number of hidden layers in between input and output layers. When you call sequential, yes, a empty network is created, input with input and output. But when you call dense, then you are able to insert some hidden layers in between. All right. So model is equals to sequential. So you are creating one model, one instance of sequence, one instance of sequential. Now you are initiating a neural network, and then you're adding input layer, weights, activation functions, which means you are trying to add model.add dense layer, one dense layer with 11 values, 11 inputs. Okay, then you are initializing it with random uniform, which means it's a initialization technique where it will take the values randomly, but it has to be the uniform data, right? So next, the activation function, the ReLU function, sigmoid function, these are all the activation functions that you might have to look into. Let me try to show it to you. I guess, do we have? Yeah. So yeah, so threshold function, sigmoid function, rectifier, hyperbolic tangent function. In the same way, ReLU is also one sigmoid function which is used widely for these kind of AI mechanisms. Right? This is one input layer. You have to initialize it. Next, this is first layer with 11 inputs. Even the input layer is called as dense layer 1. The next layer, add a hidden layer. We have to add a hidden layer. Model that add dense of how many layers should be there? There have to be 3 levels in hidden layer. Again, random uniform activation ReLU. Then output layer dense. You have to have only one output, right? So only one output. Initialization again, random uniform activation function. Here you are using sigmoid function. So just because you have to categorize things now, you have to predict things. What is their salary, whether they're gonna be there in the company or not. What is the use case we took? Just a second. We have taken churn modeling. Churn in the sense whether the person is going to be there in the company or not. So depending upon the customer, depending upon the gender and a lot of other things, whether they're gonna use this product or not, whether they stay there in the company or not. Okay, these kind of use cases. Now what is happening? We require only one output, yes or no, whether they are gonna be there or not. So we use sigmoid function over here. We are using ReLU function because this is a multiple opportunity. We cannot say what can be the next input or what can be the next output. So a ReLU function is used, and when it comes to output has to be done to decide whether it's 0 or 1. So we are using sigmoid function. Now that the model is done, now we have created all the output layers and all. When you stop adding dense layers, so that will be end of your network. So once you are done with it, you can start compiling it. Like there is no something like 1, 2, 3. You do not mention those names. Once you stop adding it, you can start compiling the model. So model.compile, which optimizer or the optimization you have, there is a technique of optimization. You can optimize the data in the complete network and bring it back to a level where you can function accurately. Then if there are any losses, how to handle the losses. Why are these things essential? See, when you are creating everything with your own hands, when you are creating everything manually, you have a tendency to go back and check those things, right? You have a back propagation mechanism. While doing back propagation, what are the things that have to be used? So this atom is something called batch gradient descent. It will use the gradient descent mechanism. Gradient descent is that U shape that I have told. It comes from one point to another point, and then it check for the minimum error, and it gets stabilized at one point. So that is called optimization, error optimization. For error optimization, see, in this epoch 1, the loss is 0.6, accuracy is 79%. Again, epoch 2, the same thing, accuracy is 79, loss is 0.46. So in the same way, it will get epochs around 150. So what is happening here? I'm compiling it. You know how the program compiles. Everyone have compiled their own C languages or Python languages here. Is it fine now? Okay, so these 3 things are essential to compile a model. So what we have done, we have created an empty network. We have created a dense layers, input layer, hidden layer, output layer. we have used some initializations, we have used some sigmoid functions, or activation functions. Activation function is nothing but the function or the mathematical function that is inside the neuron, which actually matters, is called as activation function. Okay, so now we have come across epochs. For every epoch, there is a change in loss, 0.36, 0.35, and accuracy is getting increased, right? So now what we are going to do, we are going to predict. From here, it is going to be again the same way what you have done for machine learning. So y is equals to model dot predict of y test. So we have trained the data using the training data, and we are now testing the X test, and we have predicted values. And from again, same confusion matrix or performance matrix. Confusion matrix. So this is a kind of data mining concept as well. You might have come across true, false, true, positive, false, negative, false, positive, false, negative, true, positive. So these are the things that are there. So there is a matrix. Okay. So true, positive, false, positive, false, negative, true, negative. So I think you have a little bit of idea about what this represents. So this representation has been given over here. Okay, true, positive, true, negative, false, positive, false, negative. So this is the summary of how the data prediction has been done. And looking at all those things, the accuracy is 0.5. So now, if you are given any new data, how can you predict those things? You have to first understand what the input is given. So yeah, this is in encoding format. Okay, fine. So let us change these things into 0.52, 0.8, 0.98 to 0.88 or 87. So what I'm doing is I'm trying to change the actual values over there in order to get some output out of it. Okay, it is not taking this. Fine. So you can also give individual input. So when you're giving individual input, let's see for one how it acts. Okay, input. So the input value should be same. What length of the matter, the shape of the input matters here. So what shape has been given for the X test has to be similar. So this is the shape. So this has to be replicated, and only then it will be executed. When it comes to granular level, when you are trying to integrate these things with the real world scenarios, so this complete picture will be made as a Docker image, or they can be made as a thing, real-time applications. Okay, so it can be this. You can upload it in a server. You can upload it in a server which is continuously running, and it can take the inputs in a real-time basis, and it will produce, while it is continuously running the model again and again. It will take the input and it will produce some outputs, and it will again check the accuracies, come back to the input process and check the accuracies, produce the results again. And in the same way, the output will be corrected to the some electronic mechanism, where if the input is 0, you are gonna provide in Arduino, where if the output from this particular file is 0, then switch on the light. If the input from this particular file is 1, then switch on the fan, something like this. So using image recognition, okay, let me show this one simple example. So yeah, so the same way you have now, previously we have seen things like just adding the layers and adding the dense layers and such things. Now this is a crop protection code, which means when you in the farms and all, if there are any animals that are coming and disturbing your farming, so you all the time you cannot sit and monitor. So we are using these artificial neural networks to monitor your crops and make sure animals are not there. Even though if there are animals present, you have to have a warning and then you can take some action towards it. So what is there? What are the steps involved? Same as sequential to create a base network, dense to add hidden layers. What matters here is convolutional 2D to convert the image into your 2D format, max pooling to pull the information out of the image, to flatten, to convert all of these images into one array formats, array nodes. So these three things are extra for images, and this is a basic neural network structure. Once this basic neural network structure is filled up, now you can add these three parameters or three packages to make sure the images are getting involved. So now I have started sequential, I have started using convolutional 2D network. So there is input and there is activation again. So from this convolutional neural network, again I am taking max pooling. So once the pooling is done, the size of the pooling. So these notations you will come across, for this particular input, the shape has to be this. In this complete shape, the pool size must be 2 by 2. Only the 2 by 2, only the very important things have to be recognized. Then this will be flattened and it will be given to the layer. So until here, it is the basic image oriented process, convolution 2D, pooling and flattening. So once the flattening is done, this flattening images or the flattening values will be given for the dense layers. Again, from here it's again same. The only thing is you are including convolutional 2D, max pooling and flattening in between the sequential and dense. So in between sequential and dense, you are having these three as new elements: 2D, max pooling and flatten. Once these are done, add dense units, activation function, initialization. Again, one more. This is the input. You can generate the data automatically. Hello. Yes, you can generate the data by giving one sample data. So let's say, let us get you within one example, simple example, how you can understand. Okay, so this is an example of image data generated. So there is only one image, but it is twisting the image, it is stretching, it is reversing it back, it is doing up and down. So image data generator will create its own number of images as per requested, and it will understand the image in different formats. Okay, rescale, and there are a lot of things. Horizontal flip is equals to true. Zoom range, it is allowing you to zoom, share, and rescaling the images, training and testing images. Now what happens? I am taking a few animal images, and which mode is categorical, and test size is there. So what is there here? Found 1,400 images belongs to 5 classes, right? Which are bears, crows, elephants, raccoons, and rats. So there are these 5 types of images trained. So now I'm creating epochs. I'm validating data here itself. Model dot fit generator. So here we are fitting the data and we are generating the results as well. So now after this, we can do all of these training and validation steps in one go, which is by using fit generator. It will fit the data into the model, it will generate the results. Fitting means fitting the training data to the model. Model is the neural network. You can fit the training data to your model and generate the results of your validation data. Here validation data is equals to X test, which is also given in the same line. So now what happens? Okay, we can save the complete file as H5 pickle file. This is called as pickle file, which means instead of running this model again and again, we can just use this H5 file to predict the results here by future. So here also see, we are loading the model using CNN animal.h5. We are not training it again. We are not training here. We are using this H5 file to create a model. And here again, we are compiling using metrics, loss, and optimization. Now this is just an input mechanism, a basic Python code, which will take the inputs and resize frame and all. So now we're gonna take some input from one particular location. This is a process of taking using camera. Okay, camera for capturing, because but now if we take the picture, it will be my photo, not the animal photo. So let's not take the camera right now. It will get saved into this path, and if you want to predict, you can give this path over here, cv.imread. This is computer, cv2 means computer vision package. So instead of this complete path, you can give the live footage. So live camera can be attached, live path of the camera can be given to here, where it will predict, it will give it to the data and detect. Detect, where is detect given? Detect is a function that has been written for the prediction. So inside the detect function, we have model.predict of image. So these are the things model you can write on your own, and however you want, you can change this kind of function. This is a basic function which is using this model to predict in a very good format. So now what we are going to do now, if the data output is 0, okay, so we can play some sounds, or we can say something, we can give some output, we can send a message, we can give an email alert, we can have some large wings flowing from one point to another point if you are finding something. Right, it was used to execute. That's how you can connect to your real world scenarios. This is a sample example how you can connect to real world, but in actual sense, this all things will be stored in a server in a Docker format, and it will be repetitively executed until it gets to a certain output level. So that's all for my time. So this is how an artificial neural network works, and this is how you can convert image and add it to a neural network and bring some outputs, generate stuff, recognize things, and predict things and produce some results. Okay, let me stay with you until there is some output over here. Until then, I can take some questions.
Yes, participants, if you have any queries, you can unmute yourself and ask.
Thank you so much. Thank you so much, Dr. Sure. I can share this with you. I can share it to Namrata ma'am, and she can pass it on to you. So I hope this session and yesterday's session are very useful for you, and you have got a good understanding. I might not be, I was not able to make it to 100%, or explain things very clearly because of session of time. But I hope I gave you a very good overview of what is happening in AI, what is happening in machine learning, how you can approach, what are things that are actually important, and all those things. PPT, I'm not sure I can share the PPT. You do have the YouTube video live streamed, and I think you can look it back again.
Yes, participants, I think Sir Sai Yaswanth, sir, it was a very nice session.
Thank you, ma'am. Thank
It
you
was
so much
very
for the
clean
opportunity.
and clear session. I can say that one. So I hope participants got some more information about this convolution neural networks, how to process the image and what are all the steps and these things. Thank you, Sai sir. It was a very nice session. Thank you so much for accepting this as a resource person for this FDP, and it is a very big asset for us. Your sessions are very much informative. Thank you, sir.
Thank you so much, ma'am.
participants.
Thank you so much.
Thank you. Participants, I'm going to post the feedback link. Please fill the feedback link. Thank you, Sai, sir.
Yeah.
We will be having more sessions in an offline mode also.
Sure. Looking forward to it.
Yes, sir. Thank you.
Bye-bye.
Bye-bye.